general population doesn't really understand how much heat is globally used in the industrial processes. It's something like 40% of the energy-related greenhouse gas emissions comes from heating. They have a huge global potential. In the beginning, when we have the excess power from the grid, from solar or wind, then we use normal resistors to turn that electricity into heat. So you can imagine that as a giant toaster. In our case, it's heating air pressure air inside a large duct.
How did you guys, so you and Markku went from university to get power plant engineering into building a crazy company around geothermal storage. So can you guys walk us through how that actually happened? What was the initial spark?
Yeah, or a high temperature energy storage. But yeah, we were studying power plant technologies at the Tampere University of Technology. Somehow we got really interested about energy storages and energy self-sufficiency. So in the beginning, when we were still studying, it was about like sustainable energy for buildings, and so that you would actually produce your own energy there. But we have transitioned from there to the industry. In the beginning, we thought about like what kind of energy storage you should have so that you could be totally heat independent. And we were thinking about water-based energy storages, like large water tanks. But I made my master thesis on those, and after that thesis, we realized that in the future, the clean energy that has to be stored will be electrical energy. And basically, that was the light bulb moment that if you have clean electricity, then you can go as high temperatures as you want inside the storage. Then the heat is more valuable when it's at high temperature, because then you obviously can come down from there, but you can't raise it up without a heat pump.
Wow. So maybe can we dig into the physics of that? So can you explain the audience how this whole heating part works, and why does it actually make sense physically?
Yeah. So if you have, let's say, one kilowatt hour of electricity with resistors, electrical resistors, you can raise that temperature, like basically whatever temperature you desire, as long as your materials can withstand that. And that's very valuable when you can then output high temperature heat for all sorts of purposes. And in our case, in the beginning, we were thinking about that what would be the right material where we would store the heat. And first, we were thinking about just normal earth, but or soil. But then we thought that it's going to have too much organic material, and it's gonna burn and smell bad. So the next cheapest, most readily available material would then be sand. And then we started testing the idea of sand battery.
Wow. So I guess it didn't work on the first try either.
Yeah. Well, we were successful in the testing it, and we built a small demo sand battery to my grandparents' cottage in Finland, and it was amazing to see that our measurements from that small demo were only 3% off from my computer simulations. And yeah, that was amazing.
When we look at the problem itself, like what did you see in the energy system that made you think like, okay, this is broken and the normal batteries alone won't be able to fix this problem?
General population doesn't really understand how much heat is globally used in the industrial processes. It's something like 40% of the energy-related greenhouse gas emissions comes from heating. So this kind of high temperature thermal storages, they have a huge global potential to reduce the greenhouse gas emissions. And obviously, our aim is to do that profitably for the end customers and us also.
Do you have any data on this? So you mentioned 40% of all greenhouse gases. Do you have any terawatt hour estimate of how much this actually requires to be addressed?
I can't actually say a number by heart, but it has to be like many thousand terawatt hours yearly that has to be produced. Yeah.
Wow,
and it's a multi-trillion dollar market, so there's a room for quite many companies like us.
What do people get confused about using the sand battery versus the traditional lithium-ion when it comes to the best type of storage?
We are focused on producing heat out from the storage at the moment, and obviously lithium-ion batteries would be outputting electricity, so they are different. But we are actually having a R&D project ongoing in Finland, Valkeakoski, where we'll try to also output electrical energy and heat simultaneously out from the sand battery. And this will be done with conventional turbine technology. So then we would be in more similar setup than with lithium-ion batteries, but still those systems most likely will be used in places when you will have a use for that heat that will be given after the turbine, so you wouldn't be wasting that. As like many similar power plants that are currently operating when they are burning biomass or coal or gas, they are both utilizing the heat and the electricity at the same time.
And maybe if you dig a little bit deeper into what you guys are actually storing, right? So can you explain to a non-technical person, how do you actually charge this battery and how do you discharge it? So what are the simple mechanisms that are going on there?
Actually, like at least quite simple to tell how it's done. So in the beginning, when we have the excess power from the grid, from solar or wind, then we use normal resistors to turn that electricity into heat. So you can imagine that as a giant toaster that is, in our case, it's heating air inside a large duct. And then that airstream is divided into small pipes, and that goes through the sand. And the air and the sand doesn't ever mix, so that they are separated with the pipe wall. And it's a closed loop. So then when the air has given its heat to the sand, it returns with the help of industrial fan to the resistors, and that loop just goes around and around. And then when we need heat out from the system, the process is reversed. So then the sand heats the air, and the air gives its heat to the heat exchanger, or then we can have a steam generator there to produce the steam for industrial use.
Wow. So there you go, guys. Free physics lessons from Tommi. But maybe if we segue into the value proposition of the whole system, right? Is the real value proposition that it's a lower cost, maybe a longer duration, maybe perhaps the lower carbon footprint as well? Or what is the main difference between this and a typical BESS system? What are the pros and cons?
Yeah, I think the BESS systems are used in different places, because our system would be used, like, let's say, food and beverage company needs steam for the process to produce the beverages, So there is no best system that would be producing that steam, because the amount of energy that is needed to produce that steam is so significant that you would have to invest like millions and millions, even in small scale, to that best system. So those are not done when your output of energy is heat. So it makes much more sense to store that energy as a heat when you are using heat. Majority of our customers are looking to reduce their carbon footprint in their processes, but also simultaneously trying to lower the cost of heating. And then additionally, many of them are also looking to do their share in the grid stabilization. So this called ancillary markets, when you're going to have actually quite good income from doing the grid balancing. That's like great solution for our system also, even though it's not producing electricity to the network at all, but when you are timing the consumption very well as needed from the grid, that's very useful for the grid balancing.
You touched on a couple of keywords there. So first of all, the industrial use case, right? This is becoming hotter and hotter, both in Europe and everywhere else globally. As these global supply chains are slowly disintegrating, production will need to come back home to Europe as well as to the US. So it's going to be a huge challenge to be able to support, this new demand for electricity for all of these production companies. And I think, a use case like yours will definitely be a groundbreaking help for those guys as well.
Yeah, thanks. I think so too. It's obviously super hard for the grid, like DSOs and TSOs, to actually keep the grid operating and transport enough juice for the whole economy, who is transitioning from burning stuff to do like almost everything electrically.
I hear the same, and especially from a solar perspective, we see the clear tendency, right? Last year we had, I read some points of data the other day that we had a few hundred or few thousand, negative hours in Spain and Germany as well during the peak of the summer. This year we will actually have much more of those hours. So what is becoming increasingly more important is to be able to produce more flexibly, to respond, to help the grid respond to all of these peaks and troughs, and basically to shave off that duck curve, right? And these type of solutions are exactly the solution for that issue.
Yeah, that's right. And you mentioned duck curve. So I think it was like a topic in California when it was talked about the most. When the power curve from the daily usage, it looks a little bit like a duck. When there's so much solar power production during the midday that it pushes down the need from other sources. So that's basically the back of the duck. And then during the nighttime, where the head comes from, is the peak when everyone comes to home and put their ACs to the full power and other devices at their home. So I think they have done an incredible job in California trying to mitigate that problem, because they have installed a massive amount of batteries there, and so that they wouldn't have to use like gas power so much during the night hours.
We talked a little bit about the energy density of the whole system as well, and we will also plug some slides here afterwards. But can you unpack when it comes to the lithium-ion batteries, for example? Of course, it has much higher volumetric energy density, but how does the sand actually still make sense? Can you explain the audience? We have this silo of sand, and maybe take it from here.
Yeah. So if we again we are comparing this to the best system. So let's say the use case is in California or somewhere else, where they also need electricity out from it. So we would be talking our next generation product, the sand to power here. So in the beginning, I was thinking that in lithium-ion batteries, the energy density is something like 10 times larger than in hot sand. But then when you consider that that energy density is inside the lithium-ion cell, and then when you produce a one pack from it, there's a great amount of air inside the pack. And then when you build the rack with the packs, there's again a big amount of air between those packs. And then going forward from there, your racks, I think, typically are around 2 meters tall only. And then again, there's separation between the racks if there's a fire, so that the other racks wouldn't catch the fire. So you had greatly reduced the actual energy density that can be on site when you will either buy the land or rent it. So then it's a significant cost. But in our case, we don't have that air between there. So we could basically just dig the whole system to the ground. When we are building these heat-only systems, they are in these vertical silos. But in the future, these sand-to-power systems will be horizontal in the ground or above. So we can greatly raise the energy density of the system. And actually, only rough calculations at the moment, but the end energy density can be actually 10 times higher than with lithium-ion batteries when you compare these two together. And then obviously, even the next plus is that we are also outputting thermal energy out from the system, so that can be used in industrial processes.
Wow. So basically the very long explanation short, in one case, which is the lithium ion, you fill a cup or a barrel with rocks, and in your case, you actually fill it with sand, literally. So there's no waste of space when it comes to the actual air that's in between the pieces of sand.
Yes, exactly.
But obviously, sand itself is a little bit lower energy density than the actual cells themselves. So why does this not kill the business case for your stationary storage?
Yeah, the key word probably there is the stationary storage, because then the volumetric energy density doesn't matter, and also the weight of it, because we are not doing airplanes with these sand batteries, or we are not putting those into cars or ships. So yeah, then it doesn't kill the business case. It's also significantly cheaper to produce a sand battery than a BESS system. But obviously, a better comparison would be that if you are trying to figure out how to do more sustainability and with a low cost, the low pressure steam for the industry, it's actually quite a hard thing to do because you can't use heat pumps anymore. So heat pumps would be great for up to 100 degrees Celsius. I can't remember that's in Fahrenheit, but do you?
It's around 100 degrees Celsius. It's probably going to be 300, I guess, something like that. But we'll link to that anyway.
That's basically limit for for the heat pumps to do it effectively at today. So that's out of the game because majority of that steam would be around 200 to 250 degrees Celsius. Also, you can't do a steam storage. That would be in a larger tank. That would be super expensive because you would have thick walls of steel, and then also it would be too dangerous to build a very large steam storage. But in our case, when we have just hot sand and even the air pipes are in air pressure, so there's no danger and there's no toxic chemicals involved. So it's just waiting there to be used, and our size can be even like a gigawatt hour at one side.
And we've discussed just before the recording, how this whole system actually works and how focused you guys are on the circular economy side of things as well. Can you explain the actual production process and how does one come to life? So how do you assemble it? Where do you source the sand, etc.?
I will use as an example the Pornainen system that we did just last summer. It started operating. So in there we did the whole EPC project for the end customer, Loviisallämpö, or the turnkey delivery. So we started with the groundworks, and then after that was finished, we poured a concrete slab over there. And then after the slab was cured and hardened, then we start building the steel silo on top of that. And in that case, the silo was built on site because it's 15 meters in diameter. So we couldn't road transport that to the site. But if we would have smaller systems, then we would use a metal workshop to do the silo in there and just truck it to the site. But then when the silo was finished, the great amount of pipes were added inside the silo, which transfers the heat to the sand and out from there. And in Pornainen, we actually used byproduct of Finnish fireplace manufacturing process, where in Juuka they are manufacturing fireplaces from soapstone. And obviously when they are cutting with the saw these slabs of that stone, there's these excess pieces that they can't use. So those were crushed and trucked, 50 truckloads of those to Pornainen. So 2,000 tons of soapstone is there inside that silo. And when that was finished, then we built all the equipment on top of that silo. So they are in close proximity to each other to minimize the heat loss. But since then we realized that it's actually quite much more better if we bring the equipment to the ground level, so that the project will be faster to deliver.
We've got 200 tons of soapstone, right? And once we actually assembled the whole plant, what was the capacity and what was the megawatt hour storage that we got at the end?
Yeah, so it has power in and out of 1 megawatt and energy capacity of 100 megawatt hours.
Oh, so that's quite a large storage system already.
And also, like if you compare our energy capacity to all of our competitors globally, so our storage is basically 100 hours. In that case, we can modify that a little bit, so it doesn't have to be always 100 hours. But in there for the end customer who is producing district heating with the sun battery over there. They wanted very large storage so that it's key for them to produce low priced district heating, because then they have a very wide window of time where they can cherry pick the cheapest hours from the spot market to charge this storage. And also when you have larger system, then it's better to have it on the ancillary markets, or it's easier to gain better profits from there and still lower the price of the heating.
Oh, for sure. And I mean, we've already segued into the district heating use case a little bit, but can you guys walk us through why does this make sense? And does it also make sense beyond Finland and the Nordics as well?
Yeah, we think so. There are many district heating networks in Europe and in other places globally, of course. In States, I think in many places the district heating is done with steam, so it would be even better to use sand battery over there, because then obviously the water tanks are again completely useless compared to Finland, where we have like real competition if we are trying to produce district heating with sand battery. That is the water tank better solution in there. But also our customer in Loviisalampi and also in Lahti Energia, which we are now currently building a new 2 times the size plant in Vaaksy for Lahti Energia. They saw that the sand battery is better solution compared to the water tank, mainly because it has greater energy density, so the water tank wouldn't even fit to the site. And then you have better long-term efficiency. So usually those water tanks, they are used only like 4 to 10 hours compared to ours, which is roughly 100 hours. So in the water tank, the hot and cold water are always in contact. So you will actually lose energy internally, because you would want to have like always the maximum temperature water out from the tank, but that's not possible because you have lost some of that energy from the hot water to the cold water internally, and that's a problem. And also in district heating networks, during the hardest part of the year, in the coldest times, the temperature what they need is more than 100 degrees Celsius. So anyway, you would have the water tank, but you would have to prime the temperature up with some system. So in our system, you can do all that with one system.
Yeah, and actually a question on that front. So, you know, if you have a typical lithium-ion system, of course, the colder it gets outside, the more your losses start to accumulate. How does your system behave in the cold? How does the whole silo, you know, isolate itself or retain the energy itself?
Yeah, that's a good question. Obviously, the losses are a little bit higher during the winter time. But our like yearly or long-term efficiency of the system in Bornainen, it's roughly 83% efficient. So if you would have 2 energy meters side by side, so one would charge 100 units from the grid to the resistors, you would have the district heating energy meter at the next to it. So it would say that you delivered to the network 83 units of heat, and during that time you have raised the value of the heat from the time you didn't need it to the time that you need it.
Yeah, and I mean, it's the perfect use case, right? So typically in these days, the customers are having a bigger and bigger pressure, especially on the gas price and oil price volatility, and also there is the pressure to decarbonize as well. So I mean, what is your customers' main pain? Like, what are you guys solving with the system?
Yeah, I think the main pain of our customers is the fact that they have to lower their emissions, and the second biggest is obviously to do it with lower costs. So those two are the biggest, and then also, as stated previously, they want to participate to do the grid balancing or the ancillary markets. And obviously, there's a reason for that, because they will get income while doing it.
Yeah, for sure. And, Finland is quite a unique market in terms of the solar use case as well, right? So if you're up north enough, you can actually install solar panels at a 90-degree angle, and you still catch the Arctic sun, which is a crazy thing for people to fathom, in another country, which is also very interesting. But when you guys are looking into the future, let's say in the next 5 years, what are the kind of use cases that you are focusing on developing, and where are you guys taking the system and the technology?
Yeah, so currently our all references are in the district heating use cases. So we did our first commercial system is in Kankaanpää district heating network, and our own pilot before that is in district heating network in Tampere. Our Pornainen unit is in district heating, and our next unit in Vaxu will be in district heating. But we think that it's a great use case for the sand battery to start doing steam for the industrial processes. So for food and beverage and chemical companies and other companies that produce all sorts of materials, it's a great temperature range that you will get out from sand battery. So that's where we will focus on the next years.
As I understood correctly, so most of these industrial applications are currently using hot water into steam, right? Or is that the technology that they use, or they are transitioning into the steam-based technologies?
No, so they are, when they're manufacturing something and they use steam, they are doing it either with oil or gas. So that's their energy source.
So they fuel the steam production with oil and gas?
Yes, and only few companies are doing that with burning biomass. But yeah, it's majority of it's oil and gas.
That's a huge carbon producer as well.
Yeah, exactly.
I look at a business case typically. So let's say you get in touch with a customer, what matters the most for the customer? Is it the kind of electricity spread, the fuel replacement, the utilization, the subsidies, or may it be all of the above? Can you give us some examples of how does the process typically work?
Yeah, all of the above. Yeah, we have had in Finland the energy aid from Business Finland to both of these cases in Pornainen and in Vaxu. It was roughly 30% aid for the investment or the project to the end customer.
Maybe if we dig a little bit deeper into CapEx versus heat as a service. So if anybody built a larger project, they can appreciate that usually those projects are quite CapEx intensive. You need to put up a lot of capital up front, and then you are hoping for a return over time. And you guys are actually working on a system or a solution called heat as a service. So can you give us an idea how the financing was done before, and maybe what heat as a service brings to the market?
Yeah, so previously, both in Pornainen and in Vaaksy, where we delivered this Sandberry, the customer financed the project, so they bought the EPC project from us, and obviously that's time-consuming when they need to do the investment decision in their organization, but we would like to speed things up by offering our end customers the heat as a service system, so that company that it's producing beans, they most likely want to focus on producing beans and not transition from there to be an energy company. So we would do all the hard things for them and just deliver the steam to the factory, and they would be doing that by megawatt hours. So I think that's a great way to reduce all the pain points that our customers have had.
For sure, it requires a little bit different skill sets, right? If you're producing beans versus building an energy company, which even people who are building energy companies don't really do very well sometimes. So it's a difficult nut to crack for sure.
And obviously, from our side also, we need to learn some few skills more. But we are aiming to find partners in Europe who would be our EPC partner for the system, and also the financing partner to do the heat as a service with us.
For sure. I mean, that takes quite a lot of time to build the network, but I'm sure you guys will be able to do it. And a small side note here. Can we talk a little bit about potential solutions maybe in the solar vertical, or we don't have anything to showcase there?
Basically, we don't. The only thing that we would have is that we are looking places where you would have large solar field next to like big industrial user of steam or heat, so that the whole system would be behind the meter for the end customer. So then you would skip the grid fees entirely, and that kind of cases can exist in Europe and other places.
Can we explain this a little bit in detail? So, like perhaps if you have a factory, I assume this would typically be like a commercial and industrial type of solar system, right? Because it would probably be on the roof, and then you guys would be able to complement and help the system with the sand battery as well. So, what would be the main benefits there?
Yeah, so they wouldn't have to dump the excess solar to the grid and only get like a little bit income from there, but they could dump the excess to the sand battery and then use the heat or steam locally from their own system, and then you would skip the grid fees entirely, because the whole system would be behind the meter. So that can make sense in some cases.
We've talked about the business vertical and the business level of the whole system. We talked a little bit about the physics. Like maybe let's talk a little bit more about the manufacturing side. So how do you guys actually manufacture these systems? So do you have any sort of constraints? I appreciate if you make or manufacture a large silo, it takes certain level of know-how. If you manufacture, of course, in the factory, it's easier. But if you need to manufacture and assemble on site, it's a little bit more tricky. So how does that work, or what's your experience with that?
Yeah, you are right. So in Pornainen, we manufacture the big steel silo on site because it's 15 meters in diameter. So we couldn't make that in one piece at the metal workshop and then just road transport it, because we think that in Finland like roughly the maximum diameter of the silo can be 7.5 meters that you can still road transport to the site. So it's a little bit more slow working to do it on the site. So workers of Polanite Energy are not, we don't have welders or anyone who would do like a physical work there, but we have subcontractors who are doing that. And then also the piping modules inside which transfer the heat in and out. Those are manufactured on the in the metal workshop, so that they are quite easily just done there and then fitted inside.
So you already have some sort of like know-how of how to try to standardize at least parts of the components and make them in the factory, right? It's cheaper, and then deliver those to the site, right?
We are now considering to actually standardize the like whole system in like few. We are thinking 4 different sizes now in the beginning, so that the whole system would be like absolutely ready, designed, and ready to go, and that would also have a huge benefit when we start to do this heat as a service, when the other part of the project would be faster. So we also faster to deliver that, because now our projects take a little bit more than a year on a site, and we would also obviously like to reduce that time on the site.
Yeah, of course, and I think as the side effect, you will probably also reduce the cost as well, right? So if you make it in the factory, it becomes cheaper and cheaper. And if we take a look at your experience so far, you guys built more than 10 projects already, right? So what are the main lessons that you have learned from making those projects, and that you would have been able to apply, let's say, if you went back in time to your first project versus the project that you're building right now?
Yeah, so I have to correct you a bit. We haven't built 10 projects. We have a first commercial one in Kankaanpää. So that was first, then in Pornainen, and now we are building one in Vääksy. So that will be third. But yeah, we have learned a great deal about things on the way. And obviously one most important thing is that we would like to prefabricate as much as possible on the workshops before we go to the site. But it's a little bit difficult when the system size is as big as what we have in here, but we are doing our best.
For sure. And you've touched on a little bit of the European expansion already. So I guess would the Baltics be the next logical step? And maybe second part of the same question, this is a room for your shout out as well, if you would like. What type of partners are you looking for, both in Europe and anywhere else?
We are already starting in Baltics, in near Riga, in Bolderaja, and so we would be there also producing heat to the local district heating network, and we are doing that by ourselves with our partner. We are looking in Europe partners to deliver. Basically, our system needs lots of metalwork, so companies who are producing silos, and then we have a great deal of pipes inside the system, heat exchangers, industrial blowers, and also companies who are doing the whole EPC delivery, and finally companies who would also finance with us these projects.
So if anybody of those companies is listening, please feel free to reach out to Tommi for sure.
Or some of in our company, because I might not be always seeing my emails.
What would be the best way to reach out to either yourself or the team?
Yeah, maybe email. Yep.
Okay, so we'll link to that in the show notes below, and maybe a final long-term vision type of question. So you mentioned that the idea and the goal is to become a global leader in decarbonizing the industries. What does that actually look like in 10 years? What would you like to achieve in the next 10 years?
I would like to see great, huge number of systems online, both in Europe and also then expanding globally of these power to heat systems, and then also starting some number of these sun to power units that are producing both electricity and heat at the same time. But that's in a lower TRL level if our systems that produce heat are already in TRL 9. The sun to power is in much lower level at the moment, so it will have to mature when we finalize the pilot project, and then we build the first one and so on.
Wow, very cool. So, Tommi, this has been a conversation I've been looking forward to for a long, long time, and we finally made it happen. So, thank you very much for sharing your knowledge, and let's keep each other posted.
Yeah, thanks a lot, Peter. It was super nice to talk with you.